See here, find effective resistance in series and parallel combination of three resistors. So this go they are going to ask you 4 mark question. So series combination and parallel combination. Now first we are going to write. So what is the definition of series resistance? So I'm going to write series resistance. So when you call series resistance, write a definition when when the terminal of the resistances, write definition please. When the terminal when the terminals of the resistances are connected connected to end to end connection, end to end connection connection is called series series connection series connection. Okay. Now in series connection, in series connection, point number one, current is same. Current is same. Point number two, potential difference is different in different resistances, different in different resistances. Point number three, the total resistance, the total resistance is always more than maximum resistance value. Okay, maximum resistance value. Maximum resistance value. Continuation. Kapida. Next. Now we'll draw the series connection of the three resistors. They are asking three resistors. So we have to take three resistors. Okay. Three resistors. Now this is R1 connected. The terminals are, this is R1, terminal 1, 2. Another resistance R2, 3, 4. Next 5, 6. That means the terminals of the resistors are connected end to connection. I'm joining this fellow and joining this fellow, and they are connected to a battery of voltage VT. Battery of supply voltage is VT. We call VT. So circuit is going to close. You take a switch here, a switch K. When switch K is going to close, current I is established in circuit. So what is the I into R is voltage drop. Here the potential is different, means I can call it as V1, that is equal to I R1. Voltage drop across R1 is V1 I into R1. Then similarly, this is a V2, that is equal to I R2. I R. Next, similarly, V3 IR, right? This is the, now which is different here from the circuit, from the circuit, voltage VT is equal to distributed upon three resistors V1 plus V2 plus V3. This I call equation 1. Now according to Ohm's law, V is equal to IR. P is equal to IR. So based on this, so therefore VT is equal to IRT. Similarly, V1 is equal to IR1, V2 is equal to IR2. Similarly, V3 is equal to IR3. IR3. By substituting the values of, by substituting the values of Vt, comma V1, comma V2 and V3 in equation 1. Equation 1. We get, now substitute what is the Vt? IRT is equal to IR1 plus IR2 plus IR. I is common, cancel. Cancel. Therefore, IRT is equal to R1 plus R2 plus R3. When the resistance are series, it is the formula one. So what do you need? Ohm. The unit is, okay. Series is over. Next to parallel combination. Second one is parallel combination. Write a definition. When the terminals of the resistances, when the terminals of the resistances are connected to, are connected to one common point, one common point, one common point, one common point are called resistances in parallel. Parallel. Okay. Continuation. In parallel connection. In parallel connection. Point number 1. Potential difference is same. PD is same. Now, point 2. Current is different. Current is different. Third point is the total distance is the total resistance is always less than then minimum resistance value, minimum resistance value. Okay. Now you want to that explanation. Now to see this one. Explanation. So taking three resistors. This is R1, R2, R3. So this is R1, R2, R3. I can put terminal 1, 2, 3, 4, 5, 6. They are connected to one common point. This is I'll take one point here. A is the point. I'm joining this fellow. I'm joining this one and this one. So these are parallel. So now to complete this one, again with the open terminal. Open terminal, this terminals of potential is same, but currents are different. So you want to make it to close, then current flows. Now again I can take a B here, B point, again also joining. So this is connected to switch K and battery of voltage, I can say VT. Battery of EMF is a VT total voltage. Now switch is okay. When switch is going to close, current is established in the circuit. That current I call it as IT current. Through R1, I can say I1. Through R2, I can say I2. Through R3, I can say I3. So when current is flowing in the conductor, what happens? Voltage is dropping. That voltage drop occurs R1 is I can say V1, that is equal to IR1, I1 R1 here. It is called V2, that is equal to I2 R2. And here is V3, that is equal to I3 R3. Again, same currents are coming here. This is again same IT current. Now, which is different here? Current is different. So, you have to take which equation? Current equation. So, from the circuit, now from the circuit or from the figure, which is different? Current is different. So, IT is equal to I1 plus I2 plus I3. This is equation 1. Now, according to Ohm's law, V is equal to what? IR. V is equal to IR. So therefore, I is equal to V by R. Then I can say IT is equal to VT by RT. Similarly, I1 is equal to V1 by R1. I2 is equal to V2 by R2. And I3 is equal to V3 by R3. Now substitute the values of I1, I2 in equation 1. Right here, by substituting by substituting the values of IT comma I1 comma I2 and I3 in equation 1 we get equation 1 we get equation 1 we get right. Equation 1 we get. In place of IT, you can write VT by RT. In case of I2, I1, V1 by R1. In case of I2, V2 by R2 plus V3 by R3. But in parallel, PD is same. PD is PD is same. PD is same. So therefore, VT is equal to V1 is equal to V2 is equal to V3 is equal to V same. All are equal. Now right, you can write V by RT parallel. That is V by R1, V by R2, V by R3. In place of RT, you can put parallel means P, you can put no problem. So that is all same one cancel common. Now we got 1 by RT or parallel is equal to 1 by RT is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is distance in parallel. So unit is reciprocal of resistance. It is called not ohm. It is called ohm unit, most important, right? Unit ohm inverse or mho. Symbol is MHO mho. You can write it as MHO mho or Siemens. Siemens. Siemens symbol is S. Called conductance. Can be called conductance. Now we need ohm. So this is okay. This we need ohm means again you have to take LCM and the reciprocate. So lastly, take LCM of this one. These are not ohm. Still is mho only. Not ohm. Now take an LCM. 1 by RT is equal to LCM is 1, R1, R2, R3, the LCM. R1 times R2, R3, R2 into R3 to 1 plus R2 times 1 to R1, R3 plus R3 times R1 to this thing is more only. I want to reciprocate now. Therefore, RT is equal to what you can write R1, R2, R3 divided by R1, R2 plus R2, R3. I'm writing in order plus R3, R1. Okay, na? Now this is now ohm. How can I say ohm? Ohm into ohm is ohm cube by ohm square plus ohm square plus ohm square only. Number is not important, so cancel. So answer is ohm. So unit is equal to ohm. Okay, na? Now